Welcome back. We are now going to be talking about sex chromosomes and male hormones. We're going to be talking about male and female sex chromosomes. We'll only focus on male hormones for now. Female hormones get much more complicated, and there will be an entire lesson dedicated to those. So right now we're going to be going over how sex is determined and the role of different hormones and genes in sex determination. We're going to talk about how gonadotropins help with the reproductive development of males and help their reproductive system function. We're going to look at the effects of testosterone and how it's produced, and also some of the negative feedback loops that regulate both sperm and testosterone production. So first of all, as I'm sure you're aware, in humans, the sex chromosomes are X and Y. If you have the chromosomes XX, that means you're a female. If you have the chromosome pairing XY, that is a male. Essentially, maleness is determined by the presence of a Y chromosome. If there's no Y chromosome, there won't be a male produced. There are other sex chromosome combinations like XXY and stuff like that, but we'll talk about those more in the genetics unit. For now, we're just going to look at the basic XX and XY pairings. On the Y chromosome, which is the male sex determining chromosome, there is a gene called TDF, which is testis determining factor. Essentially, if this gene is present, it determines that there will be testes present. It does that by triggering the production of male sex hormones, which are called androgens. So about the 7th week of embryonic development is when the sex organs start to develop, and those sex organs, which sex organs develop will be based on whether those androgens are present or not, those male sex hormones. If those male sex hormones are present, they will then initiate the development of male sex organs and ducts in the developing fetus. If those male sex hormones aren't present, then the embryo will continue to develop as a female. At puberty, obviously hormone levels then change. Testosterone levels, for instance, will increase during puberty, which will then initiate the development of the secondary sex characteristics. It is testosterone that is responsible for the development of secondary sex characteristics in males, like facial hair, body odor, deeper voice, all that kind of stuff. This is when the reproductive system also finishes developing and becomes functional. Both the hypothalamus and pituitary gland are in control of the production of the male sex hormones and the production of sperm as well. So when we're talking about gonadotropins in males, you have the gonadotropic releasing hormone, GnRH, that we've talked about before, that gets released from the hypothalamus. That is going to go to the anterior pituitary and stimulate the release of the gonadotropins, LH and FSH. FSH is going to cause sperm production in the seminiferous tubules. LH is going to cause testosterone production in the interstitial cells, all of which is happening inside the testes. So like I said, testosterone is produced in the interstitial cells of the testes. It is the primary male sex hormone, so it's going to cause the testes to mature, the penis to mature, sperm to start forming, spermatogenesis. All of that is the response of testosterone. Testosterone, like I said, is also going to regulate the secondary sex characteristics, all of those different things that develop during puberty. It's going to lead to more muscle growth, more acne because of the oils on the skin, and also increases both sex drive and aggressive behaviors. There are important negative feedback loops that regulate both the production of sperm and the production of testosterone. If sperm levels get too high, the Sertoli cells inside the seminiferous tubules are going to produce and secrete inhibin, which is a hormone. The inhibin is then responsible for the negative feedback loop. The inhibin goes back up to the pituitary gland and cuts off the production and secretion of FSH. It's also going to inhibit the production and secretion of the gonadotropin-releasing hormone from the hypothalamus. And then when it comes to testosterone, again, LH is what stimulates the interstitial cells to produce testosterone. If the testosterone levels get too high, it's going to have a negative feedback loop. It's going to go back and cut off the production of gonadotropin-releasing hormone, which will in turn cut off the production of luteinizing hormone, LH. And then once the LH levels drop, testosterone production will stop, and then testosterone levels will go back to normal. Okay, what I think I'm going to do now is flip over the camera and do a little flow chart, kind of showing how the hormones affect the production of sperm and testosterone and the negative feedback loops as well. Okay, so we're going to start at the top, like always, with our hypothalamus. The hypothalamus is going to release gonadotropin-releasing hormone, GnRH, which is going to go to the anterior pituitary. And then the anterior pituitary will release the FSH and the LH. The FSH is going to go to the Sertoli cells inside the testes, inside the seminiferous tubules. Seminiferous tubules. And then the Sertoli cells are going to stimulate spermatogenesis, so sperm production. Okay, which is going to increase sperm levels. Now, if those levels of sperm get high, that is going to stimulate the Sertoli cells to release the hormone called inhibin. That inhibin is then going to go and cut off the production of FSH and also cut off the production of gonadotropin-releasing hormone. LH, on the other hand, is going to go to the interstitial cells, which I don't know how to spell. The interstitial cells are then going to be responsible for the production of testosterone. Okay. And then again, that testosterone is responsible for a bunch of different things, like the secondary sex characteristics, like sex drive and aggression, lots of different stuff, okay? If the testosterone levels get too high, they will go back and also cut off the gonadotropin-releasing hormone, which will in turn stop this entire process. Okay, and that is all for today's lesson.